Welcome back. We are going to look at some MATLAB stuff now. So before we begin the MATLAB stuff, let's say we have a function or a transfer function. Let's say we have g of s, simple one first. G of s is equal to 1 over s plus 2. Now this is in the frequency domain. Okay, this s is actually j omega, so this is called in the frequency domain. So this is in the frequency domain. Now what we would like to do is we want to find out what is the inverse Laplace transform of this. So basically we are interested in doing the inverse. This is how you put inverse Laplace transform, okay? So g of s, take inverse of both the sides. So inverse Laplace transformation of 1 over s plus 2. Okay, so this is called, let's write it here. This is called inverse Laplace transform. Inverse Laplace transform. So what this is going to do is, this is going to convert the S domain to the time domain. Well, remember, if you recall, in the beginning of last week, I gave you a table from which you can find the inverse Laplace transform of this transfer function. Well, if you recall, this is really equal to the format of 1 over s plus a, isn't it? Where a, in our case, is equal to, if you really look at it, the inverse Laplace transform of this from the table is e to the power of negative at, right? So a in our case is just equal to 2, right? So the inverse Laplace transform of this transfer function, which is inverse of gs, is simply going to be equal to what? Let's think about that. So a is equal to 2, right? So the answer is going to be negative 2t. So we can pretty much say that g of t in time domain now is equal to e to the power of negative 2t. Now you can do the same stuff using MATLAB. That's where the tools come in from. So in the MATLAB, I am going to share my screen for the MATLAB too, but MATLAB is that software where you can do a lot of stuff, a lot of engineering stuff, such as even solve your calculus problems, if you will, do differential equations, and all those kind of things can be done in MATLAB. Can be used for your circuit analysis, graphing, and so on and so forth. For our purpose, what we are going to use is we're going to use the symbolic portion of our MATLAB to define symbolic to define our symbols, right? To define our symbol. Define our symbol. So in a frequency domain, as you could see from the function, we had g of s is equal to 1 over s plus 2, right? So the only variable or the only symbol that we need to define is s, right? So we need to define s. We need to define s. Well, how do we do this in MATLAB? Well, I'm going to take you to the MATLAB prompt, but just to let you know that you can create an M file and you can also do it from the command prompt. In a minute, I'll take you there. So the command prompt is going to come like this. Then there's a command called sims, which declares your symbol. So in our case, our symbol is S. And then hit the semicolon so that the MATLAB doesn't display that on the next screen. You put a semicolon right there. And now we are able to define our function. So we can say g is equal to 1 over s plus 2, and then put a semicolon again. And now there's another command called I Laplace, okay? I Laplace means inverse Laplace transform of the given function. So I can actually put this g is equal to inverse Laplace form of g, the big G. And I still put a semicolon because I want to put it another symbol, another command, which is called pretty G. That means that it's in a printable format, okay? So G, I'm going to put this, and you will see that the MATLAB is going to give you the answer e to the power of negative 2t, which is indeed the inverse Laplace transform of that function, the transfer function that was given to us. Well, I guess I will show you the MATLAB in the next video, so I'll see you shortly. Thank you.